All right, hello again, everyone. Today we're still working with exponential equations. Today we're going to go over how to graph, or rather how to take a exponential graph like this one, and write an equation out of it. So yesterday we kind of did the opposite of that. We took an equation, figured out how to graph it, how to fill out a table. Today we're going to learn the opposite. So there are really only two pieces of information you need to find. It's kind of the same as finding a slope and y-intercept. So all you need to find are the starting value and the growth or decay factor. And then you just make an equation out of it. So two things we need to find. It's a little bit more complicated than finding the slope. But here we're going to start by finding the starting value. Now the starting value is where your graph crosses the y-axis. So this point right here at 4, that would be considered the starting value because that is where your graph is going to begin. So whenever x is equal to 0, that's what you get. The growth or decay factor is a little bit different. So we can see as we go up to the next point over is 1, 8, and then the next point after that is 2, 16. So in this case, you wouldn't just say that the slope is 4 because it's not, it's going up 1 and over 4, but that's not how you find how much something is changing with an exponential function. You want to think about what we're multiplying our original value by. So our original value is 4, and to get the next number 8, what are we going to multiply 4 by? Well, that would be 2, right? 4 times 2 is 8. And then we can think about the next number over. So as we go over to 2, it goes up to 16. So obviously 8 times 2 is 16. So that number would check out. So that means my equation is y equals, the next number is the starting value. So 4 times 2 to the power x. That'll be it. So you just need to put those numbers into the right spot. So the 4 goes into where the starting value goes, and the 2 goes into where the growth or decay factor. And we can add also the note that is growth. And we can tell that's growth because the graph is going up. Pretty simple. So let's try out another example. In this example, we notice that our graph is going down, so we know we're going to have decay, but let's find out what the starting value is. So if we look right here, we can see that there's a starting value at 3. So starting value of 3. When we look at the growth or decay factor, first of all, I know it's decay, so I know that my factor has to be less than 1. It should be between 0 and 1 because it's going down. And if I look over, so that was at 3, the next point over is like 1.5-ish. We're not quite sure about that. It's kind of hard to tell where that point is right there. So I'll go the other direction. So if I go to the left one, it goes up to 6. And then if I go left another one to -2, it goes up to 12. So if you go backwards and you're multiplying by 2, that's the same as going in this direction and dividing by 2. 3 divided by 2 is 1.5. But this doesn't have to do with division. So instead of dividing by 2, what's the way that you could multiply by something which is the same as dividing by 2? Well, that would be 1/2, right? The growth or decay factor here is 1/2. So that's the decay factor because it's going down. So that means that my equation is y equals 3, that's the starting value, times, let me put in some, let's make this look good. Put in some parentheses, and 1/2 to the x. There we go. So 3 times 1/2 to the x, because that's our starting value right there, and that right there is our decay factor, is the 1/2. So that's how that works. All right, next one. Something pretty similar. This is also decay. So if we look at our starting value, where does that start right there? Well, that is a 5. Growth or decay factor, this is looking similar, but it goes down to about 2.5. If I go backwards, it goes from 5 to 10. So the opposite of multiplying by 2 is dividing by 2, or multiplying by 1/2. And that is again decay. So very similarly, this equation is y equals 5 times, again, let's make that look good with some brackets, 1/2 to the power x. So that would be our equation right there. Very similar to the last one. We just kind of changed the number that we're starting with. So it starts with a 5, not with a 3. And you can see how both of those equations, or both of those graphs, look very similar. We still have the same decay rate, or the same decay factor. But because we started somewhere else, it just will be a little bit different. Now let's do another example, another growth example. This one starts at that one starts at 3. And the growth or decay factor here, well, as I go over 1, remember, it's always what do we get to when we move over just 1 unit. The next unit over is at 6, and then the next unit over is at 12. So we're multiplying by 2. That is growth. So that means that my equation is y equals 3 times 2 to the x. Oh, done. And that's it. So all you need to know to take a graph and turn it into an equation is just finding that point where it crosses the y-axis and then moving over 1 unit and seeing what the next number is and just figuring out what do I have to multiply by to get that. Just check it. That's it. So if you have any questions, please come ask me questions on the either through email or during office hours. And good luck on this homework, guys. Have a good day.